standalone ISA server deployment scenario. After that, we'll talk about the different types of ISA server clients. There are 3 types of ISA server clients: the SecureNAT client, the Web Proxy Client, and the Firewall client. After that, we'll talk some about server publishing, actually web server publishing, and quote server publishing. And finally, we'll talk about some troubleshooting techniques using the log files created by ISA server, the firewall log, the web proxy log, and the packet filter log. Hopefully Jim will be here for that because he has the sample log files that we're going to use. So we'll start off talking about different deployment scenarios, and there are 2 major ones. There's the enterprise array deployment scenario, which is designed for larger organizations that require joining or associating multiple ISA servers in a single logical array. If you're familiar with Proxy Server 2.0, you know that you can join multiple proxy servers into a caching array. Well, this is what's required. You have to use an enterprise configuration to get a web caching array. The other primary deployment scenario is a standalone ISA server. I'm going to switch between ISA and ISA. I like ISA, but sometimes I get tired of pronouncing ISA. The standalone ISA server cannot participate in a web caching array. There's no way to join standalones. Okay. What's significant for you as an implementer, in addition to the functionality of the enterprise and standalone ISA server, is the cost. The standalone ISA server product, or standard edition, is $1,499 per processor, and the enterprise version is, I believe, $59.99 per processor. Okay? Not cheap, but not necessarily as expensive as the competitors, especially considering that VPN capability is built into the ISA server configuration. So enterprise arrays, let's start with that. What does the enterprise array allow you to do? It allows you to manage domain security policy, or I should say domain firewall policy, in a centralized location. The firewall policy is stored in the Active Directory. Okay? It's not stored in the registry on the local machine when you create enterprise arrays. An enterprise array can include just a single ISA server, too. All members of an enterprise array, and you can only create an enterprise array with the enterprise version of ISA server, have to be members of the same Active Directory site. And Laura went over some Active Directory concepts. I'll show you the Active Directory Sites and Services console here. So they have to be members of the same domain and the same site. Okay? Someone asked me the other day, well, can I put ISA server in Los Angeles and another one in Tokyo and have them act as a caching array? Well, I suppose you could do that if you were well connected, but it probably isn't the best thing for you to do. Okay. You can create multiple enterprise policies. For example, you can have, because the enterprise policy allows centralized management, you can create a policy for your Southwest division, your Northwest division, your European division, and your South Asian division. And you can store those in your Active Directory, and you can manage them centrally. You don't have to go hopping about the world over the network in order to manage multiple security policies for your ISA servers. You can do it all from a single location. However, if you do use enterprise policies, you can't allow the local array administrator some control. You can allow them some degree of control. For example, 1400. This is a dialog box for the array where we can see the Policies tab. And in this example, we're using a custom enterprise policy that's stored in the Active Directory, but we allow array-level access policies that can be used to restrict the enterprise policy. And that's a significant concept when you're using enterprise policies. You, as the enterprise firewall administrator, set essentially the rate-limiting access policies. The array administrator cannot exceed the rate-limiting policies that you set. However, they can further restrict the policies that you create on the enterprise level. Only by creating enterprise arrays with the enterprise version of ISA Server can you create a caching server taking advantage of the caching array routing protocol, which was available in Proxy Server 2.0 and is available in ISA Server only in the enterprise version. I know several people that got caught up said, well, $1,499 for a single processor, I'll just buy 3 of these and create an array like I did with Proxy 2.0. Well, that won't work. You won't be able to join them into an array. You have to have the enterprise version. In order to create an array, objects have to be added to the Active Directory because the configuration is stored in the Active Directory. And it's about 12 megs of material that's added to the Active Directory, which will be included in replication too. Not a significant amount, but something you should be aware of. So, in contrast to the enterprise configuration, it's a standalone ISA Server configuration. Does not support enterprise arrays. Active Directory is not required. Okay? There are still a large number of organizations that, for a variety of reasons, don't want to run Active Directory. They spent 5 years getting their NT domain structure stable. And they don't want to they don't want to feel like they wasted their time and all that effort. So you can join, and you can take advantage of your NT domain environment by joining standalone ISA servers to the domain. Okay. The ISA computer must be a member of the NT domain, and there's no problems with that. But it still has to be installed on a Windows 2000 server. The Windows 2000 server has to be a member server in the NT domain. Okay. Like I said earlier, there's no distributed caching available. You can't join them into a caching array. However, hierarchical caching is available. For example, let's say that you have an office in Beaumont, Texas, and you have another office in Pasadena, Texas, and you have another one in Gun Barrel City, Texas, and your main office is in Dallas. What you can do is you can put an ISA server at the edge. Gun Barrel City is about 20 miles down the road, okay, from where we live. You can put an ISA server at the edge of each of those branch networks, and what will happen is that when users at a branch office make a request for a web object, a URL, the request goes to the branch ISA server first. ISA server looks and says, I don't have this. What I'll do is I'll go ask the ISA server upstream in Dallas to see if he has it. If the ISA server upstream in Dallas has it, then he sends the answer back to Gun Barrel City or Pasadena, who returns the result to the user, and he also caches it locally as well. So this reduces the amount of traffic on the external interface of the ISA server. The standalone ISA server is definitely the easiest one to configure because there are quirks in the enterprise configuration. I should say not quirks, but there are things you need to consider when you're merging the enterprise policies with the local array policies. Okay, so it's much easier to configure the standalone. Standalone is suitable for small and medium businesses. Single people say, Tom, I got a box, that has 4 gigs of RAM. It's a dual Pentium 3 700. How many users can I have behind that box? And of course, like all other answers, it says, well, it depends. The answer to all questions is it depends. It depends on how many rules you have, but if you have just a small handful of rules, it could easily handle 5,000 to 10,000 users with that single box, depending on, of course, if your external interface is a 64K modem, ISDN modem, you're not going to handle that many. But it won't stress the box. It might stress the external interface, but it won't stress the box to have that many users. Beef up the hardware. I'm going to do Jim's section for him. Jim, are you here yet? No Superman. Okay. Any questions so far? No? Do you know what ISA Server does? It's a firewall and a web caching server. It's like Checkpoint, except it's cheaper. And it integrates with Windows 2000 very nicely. ISA Server clients, 3 types. The web proxy client. The web proxy client is a browser, a CERN-compatible browser that's configured to use the ISA server to access the internet. Okay. A common misconception that I have to deal with, well, Tom, the boss says no client software on the computers, so I can't run the web proxy client. I said, well, do you run a web browser? I said, yeah. I said, well, just configure the web browser to use the IP address of the ISA server for its proxy, and it becomes a web proxy client. Oh, okay. Well, no additional software, right? Now there's configuration, but if you run a Active Directory domain, you can make that configuration via group policy, a total no-brainer. Take 15 seconds to set up, refresh the policy, and you're set. Like the web proxy client configuration Proxy 2.0, the web proxy client configuration only supports HTTP, HTTPS, SSL, or TLS, FTP, I should say tunneled FTP, because the FTP requests are tunneled in an HTTP request to the web proxy service, and Gopher. Okay. That FTP issue is an important one, and I'll bring it up again later. And finally, the web proxy client is operating system independent. So if you're running Macs, Unix, Linux, whatever, as long as the browser itself is a CERN compliant browser, then it can be configured to use ISA server as its web proxy server. The SecureNAT client is new, was not, there's no comparable client configuration in Proxy Server 2.0. What the SecureNAT client is a computer whose default gateway is configured to route internet-bound requests to the internal interface, the LAN interface of the ISA server. That's it. That's a SecureNAT client, okay. Which makes it transparent proxy client. If all you have to do is set a default gateway, would you call that a transparent proxy? Sure, no client software required. All computers have to have a default gateway if they're going to access the internet or any other network ID other than their local subnet. Okay. SecureNAT supports a subset of protocols. Unlike the firewall client, the SecureNAT client supports only protocols that are included in the protocol definitions node of the ISA management console. Key thing, people just, Tom, how come this doesn't work? How come this doesn't? Well, because the SecureNAT client only supports the protocols that you have configured in the ISA management console already. So, well, how come I can't get MSN Messenger to work? Well, because some of the protocols that you require are not included. You're going to have to run the firewall client instead. Also, the SecureNAT client doesn't support protocols that require secondary connections, unless there is an application filter that's mediating the conversation. For example, what is our classic protocol that requires a secondary connection? FTP, exactly. Okay. The SecureNAT client by design won't work with FTP because it requires that secondary connection if you're using port mode inbound TCP/20, right? Okay, from TCP/20. But there's an FTP application filter that listens in on the conversations and is able to mediate the negotiation of ports for the FTP communication. So that's why SecureNAT will work with FTP. However, SecureNAT will not work with the MSN Messenger in Windows XP because it requires universal plug-and-play and dynamic configuration of ports for voice and video. There's no fix for this. Tom, voice and video doesn't work. Tom, voice and video. That's right, it doesn't work. It doesn't work because it can't work until the team puts together an application layer gateway for voice and video for the MSN Messenger. Okay, that's all. Until then, you can use NetMeeting and the H323 gateway that comes with ISA Server. Said, well, okay, Tom, how come my brother can call me? My brother can call me and we can do voice and video, so obviously you're FOS again. Well, not maybe before I was, but the reason why you can this time is because he was directly connected to the internet and he was able to call you because he wasn't going through a NAT or any other kind of gateway, and that's the only situation where the MSN Messenger will work. Excuse me. The last client is the firewall client. The firewall client is comparable to the WinSock proxy client with Proxy 2.0. Okay, the firewall client has a lot of intelligence with it because it's able to communicate, the protocol is able to communicate its requirements with the firewall service or the WinSock proxy service on the ISA server. So now you can have complex protocol conversations such as FTP, H323, and others, without having an application layer gateway in between, because essentially the firewall service acts as that application layer gateway. So you can run complex protocols with secondary connections without having predefined them in the ISA Server Management Console. Firewall client works on all Windows clients, but is not cross-platform. And actually, it works for all, quote, 32-bit Windows clients. What's the oldest 32-bit Windows client? '98 SE? No. What? Remember Mick Jagger was singing about 32 bits? Windows 95, okay? Windows 95. So the firewall client software will not work with Windows 3.1. However, if you have the old WinSock proxy client from Proxy Server 2.0, that works just fine with ISA Server. ISA architecture. Question?
If you have a client set up as a SecureNAT client,
okay,
and load the firewall client on him, what happens? It doesn't matter.
Oh, yeah, it matters a lot. That's a good question. Okay, the question was, I've got a client on the internal network that accesses the internet via the ISA server. I've configured him with the firewall client, and now I've made him a SNAT or SecureNAT client. What's the effect of that sort of thing? The firewall client only mediates TCP and UDP communications. Any TCP or UDP communication that is sent from the internal network client to the internet is going to be snagged by the firewall client software and remoted to the ISA server. Any other protocols, any other transport layer protocols, such as ICMP and GRE, are going to be handled by the SecureNAT client configuration. Well, so what? As long as I get my communications out to the internet and get my responses, I don't care if firewall client, SNAT, or whoever takes care of it. Well, it's important because there's no access controls. There's no access controls over those protocols. For example, ISA Server allows PPTP pass-through, so internal network clients can call external network internet VPN servers, which is pretty convenient. It does not perform L2TP over IPsec pass-through, though. Well, that's real convenient, except if you allow that, everybody who's a SecureNAT client has access. Everybody on your internal network will be able to make outbound PPTP calls. Okay? Same thing with ICMP too, so everyone's going to be able to ping, do trace routes, whatever. There's no access control. So if you give it to one person, everyone else who's a SecureNAT client is going to be able to do that too.
Aren't you limited by IP though? Your SecureNAT people? You have some packets, right? Or no?
None, because that's a good question, because you can use protocol rules to control outbound access based on the client IP address or the user, right? Except SecureNAT clients can only be controlled by what the IP address of the client is on the internal client. But that only applies to TCP and UDP-based protocols. You can't create protocol rules for non-TCP or UDP protocols. Make sense? I mean, does it make sense that that's how it works? Not, does it make sense that that's why they built it that way?
So, all right, one final question. Well, I take that back. In an IPX internal environment where I'm routing out proxy TCP IP, does that have anything to do?
IPX?
Yeah. If you have IPX internally and you're proxying out web traffic via IPX, how does the firewall SecureNAT? How's all that?
Oh, okay, Tim just came up with an ideal security environment for protecting the internal network clients because he's using IPX. The reason why is there'll be absolutely no inbound or outbound access because ISA Server doesn't support IPX SPX. Okay, unlike Proxy 2.0.
Proxy did? ISA Server doesn't do that?
Does not, no. Legacy protocol and all that, you know. Yeah. Let's reinforce that point is that ISA does not support IPX on the internal network. You must use TCP/IP. More interesting information about client support is the ISA Server has a built-in DNS cache for web and firewall clients. One common configuration issue that drives people bananas is their name resolution, their host name resolution for internet hosts. So, well, I configured the DNS server on my web proxy and firewall client, but it's not working. Why is it not working? The reason why is the firewall client and the SecureNAT firewall client and the web proxy client allow the ISA server to perform name resolution on their behalf. Okay. What's also interesting is, well, I should be able to see the DNS cache on the ISA server by running what ipconfig/display DNS, right? Except that's not the cache that ISA server uses. Doesn't use the DNS client cache. It has its own proprietary cache, okay, which has a half-life, TTL. That's an old career half-life. So TTL of 6 hours by default. Now that's configurable in the registry. You can reduce the TTL on the DNS cache on the ISA server. Okay. You can force a web proxy and SecureNAT clients via the HTTP redirector. The web proxy service is the service that's responsible for the caching of web requests. And the caching of web requests increases performance and decreases response time for web proxy clients in accessing internet objects, because previously accessed objects are in the cache already. Now, what about SecureNAT firewall clients, I don't want to configure my browsers as web proxy clients. That's too much work. I don't want to install the firewall client software, which is an additional piece of software, but I want to take advantage of that web proxy cache that I paid for. Okay, well, you can do that because there is a piece of software called the HTTP redirector that forwards requests from SecureNAT clients on the internal network to the web proxy service. Okay. Now, what if you're in a situation where I only want people who can authenticate? I want people to authenticate by their username to access the internet, access the web, HTTP, tunneled FTP, and HTTPS. Well, you don't want SecureNAT clients because SecureNAT clients can't send their credentials to the ISA server. Okay. What you can do is you can turn off the HTTP redirector, prevent web requests from being forwarded through the HTTP director, and just have requests from SecureNAT clients dropped. Okay? That's one way to force authentication. The only clients that can authenticate with the ISA server, so why do I care about authentication? Well, one, you care about authentication because you want to be able to control who can access the internet, and two, you care about authentication because you want those usernames showing up in your log files so that when you make reports and you need to find out who's accessing Napster or Kazaa or Morpheus or any of the latest and greatest war-resing applications. You want to be able to find out who the user is that's responsible for all that traffic. Okay. Client access policy. Client access policy. How can you control outbound access? How can you control what people access on the internet? Well, you can create what are known as site and content rules, and site and content rules can be used to control what type of files users can access. For example, you don't want users to download zip files, so you can create a site and content rule. You don't want people to download MP3 files, you can create a site and content rule. You don't want people to go to www.hotmail.com, create a site and content rule. Don't want users to go to pages that have the words hot and money and come up with a third word of your own.
Sex.
Sex, there you go. Hot, sex, money. If you don't want users to go to those pages, you can't do that with ISA out of the box. Okay? Will not examine the HTML content. You'll have to get a third-party product like LandGuard. Protocol rules are used to control what protocols users can access. Okay? Do your temporary workers need to access IRC? Do they need to access TCP 1214, which is used for what? I'm proud of y'all that you don't know that one. Because that's the Morpheus one. Yeah, Morpheus. Do they need access to that? No. Okay. You want to be able to use least privilege in terms of access. So that temp, they may need access to HTTP to access whatever, or maybe they only need to get email, so you give them access to SMTP. So protocol rules can be allowed to control access to different protocols. IP packet filters are not a method of controlling client access because they can't do that. What IP packet filters can do is support services and applications that are running on the ISA server itself. Okay? Nothing else. I see very common configuration error is that people will try to allow outbound access for difficult to configure protocols by creating packet filters, and ISA doesn't work that way. WPAD configuration. A WPAD entry is a way to automatically configure browsers in the firewall client so that they know where the ISA server is. so that you don't have to manually configure the browsers. You can create a WPAD entry in DHCP or DNS. Okay. DHCP gives you more flexibility because you can create a different WPAD entry for each scope. If you can create WPAD entries in DNS, everybody that identifies themselves as members of a single domain gets the same WPAD entry regardless of their subnet ID, their subnet location. So that's an important distinction to make. Outgoing web requests are handled by software known as the outgoing web request listener. And it's the listener that's responsible for accepting the requests from the web proxy clients on the internal network. There's an important configuration option here. Down here at the bottom, you'll see where it says the connections frame, and then it says connection settings, and then ask unauthenticated users for identification. That, I call that the force authentication checkbox. If you want to make sure that everybody who accesses the internet through the ISA server, or I should say anyone who sends HTTP requests through the ISA server, gets authenticated so they don't access the internet anonymously, which is not helpful in log file analysis because all you'll see is anonymous, then you'll configure that checkbox, enable that checkbox. Talked earlier about the HTTP redirector. This filter, again, is responsible for intercepting HTTP requests from SecureNAT and firewall clients. And depending on how you have it configured, this is the default configuration, which is redirect to local web proxy service. HTTP redirector will forward the request from the SecureNAT and firewall clients to the web proxy service. The two other options are send to requested web server and reject HTTP requests from firewall and SecureNAT clients. The last option is very helpful in preventing users from subverting your web proxy client configuration. If you have users that like to take it upon themselves to unconfigure their browsers so as to bypass your HTTP access controls, you can get back at them and prevent them from doing so by rejecting HTTP requests from firewall and SecureNAT clients. Okay? The option send to requested web server is helpful for those applications that can't send credentials to the ISA server, but it does create some security problems, and I recommend that you don't enable that option, except for maybe yourself. Okay, we covered this. DNS COD does not mean cache on delivery. I think he meant cache of death. Okay. The reason why Jim refers to it as the DNS cache of death is because the TTL is so long and it's not coordinated with the DNS client service on the ISA server computer. Browser configuration for WPAD. After you set your WPAD entries in DNS and DHCP, go to the browser and select automatically detect settings, and that's all there is to it. And then the browser will query DHCP or DNS depending on how you have it configured. A common configuration problem goes like this. Okay. Is you have VPN clients, and they want to be able to access the web at the same time they're connected to the VPN. Anybody have experience with this? Okay, they want to be able to access the web and while they're connected to the VPN. With the default settings on the VPN client, are they able to do that? No. because you're using the default gateway on the remote network, which is the ISA server. Now, you do have the option to not use the default gateway on the remote network, but then your VPN client becomes a router, essentially, so that they can access the internet and the internal network at the same time, which is akin to allowing your internal network users to connect a modem to their workstation and bypass all the access controls that you so dutifully configured. So what you do is you want to be able to configure the VPN client's web browser so that it has to use the ISA server to access the internet. And the way to do that is you have to set the settings for the VPN connection separately. Okay? You know, when you go into the browser and go into the internet options and click on the connections tab, and there's a little button there that says LAN settings. Picture this, a little button that says LAN settings. That's the wrong button for the VPN client. What you need to do is you need to select the VPN connection and then click the properties button, and you'll see this. You set the proxy server separately for each dial-up connection or each RAS connection. For SecureNAT clients, packet filtering is enabled by default on the ISA server, and packet filtering closes off all ports on the external interface of the ISA server, except for those that you open explicitly with packet filters or server publishing rules. Okay. Now, you can also enable intrusion detection, which Microsoft has licensed from ISS, about 10 different common attacks. The enable IP routing is an important configuration, because if you don't enable IP routing on the packet filters properties dialog box, you won't be able to pass ICMP or GRE or any non-UDP or TCP protocols. Okay. Common question is, how come my clients on the internal network can't connect to a VPN server on the internet? How come I can't ping a server on the internet? How come my trace routes don't work? It's because you haven't enabled IP routing on the ISA server. Why? Because PBTP requires GRE, IP protocol 47, trace route and ping require ICMP, non-TCP, non-UDP protocols. Okay. SecureNAT clients are defined as computers who have a default gateway set so that internet-bound requests are sent to the LAN or internal interface of the ISA server. That's the definition. SecureNAT clients depend on the firewall service, and the firewall service is only available in the integrated or firewall-only modes. SecureNAT clients the SecureNAT client configuration is supported by all operating systems that run TCP/IP. Okay, won't work with IPX. You can use simple protocols. Simple meaning protocols that don't require secondary connections. SecureNAT clients cannot authenticate users. No credentials are sent from a SecureNAT client. So if you need to control access based on user and group, you have to use the firewall client or the web proxy client configuration. And very important is a SecureNAT client does not allow the ISA server to perform a proxy DNS. Okay. The SecureNAT client has to resolve its own names. The ISA server is not going to resolve host names for the SecureNAT client. Very common problem. So, common question is, hey Tom, web proxy works great. I can get to the web, but can't get email. I can't get to the news servers. What's the deal here? Well, the deal is that you have your DNS configuration on the interfaces of the ISA server working, but your SecureNAT client isn't configured to use a DNS server that can resolve internet host names, and so name resolution fails, and they can't access those protocols. So what you need to do, you need to create a protocol rule that allows the SecureNAT clients to access that protocol, the DNS. Tim, that's 5 here.
Yeah, I'm not sorry.
Don't be sorry.
So if I've got a box a couple of hops away from this guy,
Okay.
or I think what you call a complex network, and I want to do outbound VPN as a secure NAT, is the only way to do that to set up the complex network setup and have the last router forward that default gateway to the ISA server?
Exactly.
That's the only way.
Well, that sucks is kind of a strong statement.
Well,
But it's not optimal. Let's put it that way. It's not optimal, right? Because what you have to do is you have to build your infrastructure around the ISA server, right?
right.
Which you shouldn't have to do, and that's one of the advantages of the firewall client, is that the firewall client's configured with the name or IP address of the ISA server, so it doesn't matter what your routing infrastructure is.
Right, the firewall client won't pass GRE, right?
Will not, that's right. Or ICMP or...
Right. Okay. So yeah, I should...
Have you run into
It
that?
sucks because I don't know how to do it. That's what I really need.
Well, I'll tell you what it is. It's a balance. What they wanted to accomplish with the SecureNAT client was a transparent proxy, right? No configuration other than a default gateway. Yeah, it's transparent to the client, but it's not transparent to your routing infrastructure. Okay, so I guess transparency is a relative term.
I'm sorry.
Uh-huh.
No, so when you do that,
Let's go back.
by default, will make everything, I mean, whenever you route like that, so I've got my ISA server and I'm on net 1, and I've got somewhere else on net 2 that's routing up to that guy.
Okay.
If I configure it from a routing standpoint, then by default, everybody on that other net is going to be a secure NAT client? Or am I going to have to do client-based routing for this?
Okay, I see what you're saying. If you configure them, that's a I hadn't considered that before, but that's a significant side effect, isn't it? Sure. If you develop your routing infrastructure where you create a series of default routes, right? So that the route of last resort is the internal interface of the ISA server, and obviously these internal network clients require, in a complex or multi-segmented network, require default gateways to access other network IDs in your environment or other segments in your environment. Then they have to be SecureNAT clients, which means that they'll have to be allowed access to ICMP and GRE.
Right.
See? That's a good question. We'll put that in the next edition of the ISA server book. No Thor there. With great appreciation and fondness, we would like to thank. Okay. Yeah.
Related to that, if you didn't have an ISA server connected to the internet on that other segment, what would that router's default route be?
Routers?
I mean, wouldn't that router's default route go to whatever goes to the internet?
Well, I was talking about, like, if you have private IPs on net 1, net 1 is actually connected to the internet.
Right.
So net 1 has got like a .1 address. You have a .2 address somewhere. So .2 is going to route over, however, .2 is going to route over into .1 via the router that connects those guys.
Right, in order to access network 1.
Right.
Right.
So if you have .3 somewhere, you're going to have to make sure that when you're routing out of .2, that everything from .2 gets routed to the ISA server as opposed to the other internal router. If you want those dots to be...
Well, except the...
They don't have a route to that other internal segment.
Well, right. Okay, I'm seeing where the solution here is. The one on the top of the hierarchy, the one closest to the edge, if it doesn't have a route of last resort set for the internal interface of the ISA server, then it won't go out to the internet. which of course means that no clients can be configured as SecureNAT clients.
Right.
So,
I'm talking specifically as SecureNAT clients. If I want those people to be able to pass GRE, they have to be SecureNAT. So that means that whole back-end route is going to have to be SecureNAT.
and the significance of that is that there's no access control for those. Everybody has access to PPTP then, or outbound GRE. So, good point.
I'm going to pass Laura any further questions.
No, I mean, now you've earned your keep here because we got a good thing for the book. Thanks. Okay, configuration of the firewall clients. Configuration of the firewall clients. The firewall client is your most versatile client, although it requires that you install the firewall client software on the computers, which is easy to do in a small environment and less easy to do in a large environment. The reason why is to install the firewall client, you have to have administrator privileges.
To use it, can you be a regular user?
You can be a regular user to use it, but to install it, if you don't use group policy, to install it, to assign it to a computer, then the user must have administrator privileges to install the firewall client software, which they're aware of the issue and will be handled soon. Okay. The firewall client software can be made aware of the requirements of virtually any application, and that involves configuring the MSP clnt.ini file, just like with Proxy Server 2.0. I'm not going to go into too much detail into that because that's a book in itself. Okay. Web and server publishing. What time is it? Server publishing generically means making servers on your internal network available to internet users. Okay. This is a very popular thing. So rather than having to create a DMZ segment or just placing your servers directly on the internet, you can put your mail server, your web server, your news server, your FTP server on your internal privately addressed network. And the process of making them available with ISA servers is called server publishing. There are three ways to publish servers and make them available to external network clients. There's web publishing, server publishing, and packet filtering. Web publishing web publishing rules allow you to publish multiple servers with a single IP address on the external network interface, the WAN interface of the ISA server. So let's say you've got 10 servers, you've got 10 web servers on your internal network, but you only have one IP address, one public IP address that's been assigned to your organization. Well, you can make all 10 of those web servers on your internal network available to internet users by using web publishing rules. Very, very nice, and it's done via what's known as the external incoming web request listener. This is a shot of the incoming web request listener, and this server is publishing, I think, 20 web servers. And it's doing it all with a single IP address bound to the external interface of the ISA server. How does it do that? The web proxy service allows it to do that. Oh, look who's here. Mr. Jim Harrison, just flown in from Seattle.
Yeah. My pleasure to delay everything for you.
Okay. This is a real popular feature because depending where you're located, it can be very difficult to get multiple public IP addresses. Okay. The web proxy service, what it does is examines the HTTP header so that even though all the requests are going to the same external IP address on the ISA server, the web proxy service says, okay, it's coming to 64.64.64.64, but this is sent to www.stuff.com. The web proxy service has a web publishing rule associated with it that says, oh, www.stuff.com should be forwarded to 192.168.1.1 or server 1 on the internal network. You can use either IP addresses or computer names. Okay? Another nice thing about web publishing rules is that they support port redirection, okay, which is a bone of contention for many because you can't do it with server publishing rules. For example, you can have your ISA server listen on port 1, 2, 3, 4, 6. We don't want to use 1, 2, 3, 4, 5, obviously, or maybe we do. Listen on that alternate port on the external interface, but send it to port 80 on your internal network server. Okay? So you can redirect ports using the web proxy service. The web publishing rules can also redirect requests and redirect SSL requests and forward them to the internal network server over the internal network via HTTP. And it can also forward HTTP requests as SSL requests on the internal network. I can't see much use of that, but there is some utility to allowing your external network clients to establish an SSL session to the external interface of the ISA server and then have the request as it's forwarded to the internal web server be sent as HTTP. It takes the processing load off the web server on the internal network. The web publishing rules can also take advantage of the web proxy service so that inbound requests to your internal network servers are cached on the ISA server, okay, known as reverse caching. And also, the web publishing rules support plugins, such as these plugins are referred to as web applications. Server publishing allows you to publish everything. Okay, web publishing rules support publishing HTTP, HTTPS. No, supports HTTP requests only, actually. Okay, supports publishing web servers. Server publishing rules support all protocols, okay? SMTP, NNTP, FTP, you name it. You come up with it, you can create a server publishing rule. So you can put any type of server on your internal network, but you can't do port redirection, okay? If the external interface of the ISA server is listening on port TCP 25, it's going to forward that request to the internal network server on TCP 25. Okay. Okay. They also will not allow you to map IP addresses on the external interface and forward everything to an internal network server, which you can do with the Windows 2000 RSNAT, but you can't do with ISA server. Okay. However, server publishing rules can take advantage of application filters, such as the FTP application filter, which creates some issues, like with FTP, because if you create a server publishing rule to publish an FTP server on your internal network, it's only going to work if you publish it on port 21. You can't use alternate ports using a server publishing rule. Although you can publish on alternate ports, but you have to use the old firewall client method of publishing. Finally, with server publishing, you have to watch out for contention. One of the most common errors that we see is that people say, my server publishing rule doesn't work, my SMTP server publishing rule doesn't work, my NNTP server publishing rule doesn't work, my web publishing rule doesn't work. Why doesn't it work? Jim, why doesn't it work?
They forgot to turn on the machine.
They forgot to turn on the machine, the router's down.
SecureNAT.
Secure.
They publish another machine offering the same service.
That's right. The IIS hasn't been disabled, right? Or the ISS services haven't been disabled. So if you create a server publishing rule because you want to publish your internal Exchange server on TCP 25 and said, it doesn't work, it doesn't work. The reason why it doesn't work is because the IIS SMTP service on the ISA server is still on. You've got to turn it off because it's grabbed that port already. Okay. Packet filtering. Question. Packet filtering is not really publishing. It's a way of making servers on your DMZ segment available to the internet. Okay. You can make web servers, mail servers, whatever, on a DMZ, on a tri-homed ISA server, available to internet users by creating packet filters. There's very limited access controls based on IP address. Allows direct writed access to the servers. ISA doesn't use NAT of any kind to mediate the communication, and it's not recommended. Again, packet filtering is primarily used for outbound access, and inbound access for services and applications that run on the ISA server. So, thank God, my part is over. And Jim is here. Question?
Yeah, on the last slide, you said not recommended for services on the ISA server?
No, it is recommended.
No, it says right on the second bullet from the bottom, not recommended.
Oh, okay. Sharp eye. Okay. This is my personal opinion. But if you're going to publish an SMTP server, let's say you install Exchange on the ISA server, or let's say that you want to run the NNTP service on the ISA server. Instead of using packet filters, create publishing rules instead. It gives you a little bit more access control than packet filters do.
Wouldn't the appropriate recommendation be to not install IIS on the ISA server?
Well, absolutely. I mean, the best recommendation is don't put FTP servers, don't put SNTP servers, don't put your Exchange server, don't put your Quake server on ISA server. Do you put these things on your PIX device? No. So why do that to your ISA server? You're absolutely right. Don't put extraneous services on the ISA server. And so I should have just gone whole hog and said don't put anything on the ISA server except the firewall components. Makes sense? But a lot of people, especially poor souls out there that have to use SBS, are stuck, right? A small business server, you have to put everything on one computer. If you work with SBS users, you get to put Exchange and SQL and God knows what else comes in that bag. And it's a configuration nightmare. It's also a security nightmare too, as you can imagine, because everything, I mean, each service is a portal of attack, right? Each service, each application provides a portal of attack. And so that's why SBS is not a good idea. Good?
Do you have any recommendation, did you already Active Directory, what roles the ISA server should have in the Active Directory?
I mean, where should you place the Active Directory in relation to the location of the ISA server?
What, 4 or 5 roles that the different servers have in Active Directory? Is the directory, I can't remember one. You know, you can move these roles from one server to another. I can't
Single master?
Some of y'all may.
Flexible single master operations rule, something.
I'm sorry?
Are you talking about FISMA rules, your infrastructure master, domain name master?
Yes,
PC?
right.
Okay.
Those roles. So should we not have any of those roles on the ISA server? You know, we're talking about not putting all this other.
The ISA server should not be a domain controller. I mean, think about it. Think about it. The ISA server provides fine security. No one's broken it, to my knowledge, yet. However, no one's broken through the front door of my house yet either. So, should I put 100,000 in small bills on my coffee table while I leave town? Or should I put the 100 grand in small bills in a safe that's in a 50-foot basement lead lined. Well,
It should just be a member server.
should be a member server in that domain, or you create a ISA domain and create a trust, a one-way trust, where the ISA server domain trusts the internal network domain.
Can I ask one more question? Will the SecureNAT client
SecureNAT, well, SSH?
Yes.
I don't see any reason not to. It's just a port, Jim.
So just secure telnets, it's a single
Yeah.
port. As long as you're not using secondary.
But there's no secondary connections that I'm aware of.
Tim says it'll work.
Tim says it doesn't work?
No, he says it will.
Oh, it will work. Okay. Any more questions? All right, Jim. I will hand over the. Oh, thank you. By the way, after the talk, Andrew Williams, Andrew Williams, my publisher, is sponsoring the book signing after the talk and tells me that we're going to have books that I'm going to sign for free. That's my favorite word.
Don't even have to write articles. Okay, do we have Raz and a whole bit up here? Did that finally come? No? Oh, okay.
So-
We're going to wing the hell out of this one, aren't we?
We got.
Yeah, I know you've been, Tom's been up here schmoozing the whole time, waiting for me to show up. Yeah. I'm not liking this thing. Okay, everybody hear me all right? Okay, Tom took you through what was actually my favorite parts, the ISA Server clients. But what we'll do is run on through the troubleshooting side of it. Just to start off, what's your favorite problem with ISA Server? I mean, we'll start right off with a question here. What's the thing that has really kicked you in the head if you've worked with ISA Server at all?
SecureNAT, complex network.
Okay, how about one person? Okay, I'll pick a person. You don't get to play, Tom. You get to be quiet now. Okay, I heard somebody back in the back.
Yeah, but he's had a lot to say already.
Oh, so he's overspoken his bounds?
Complex networks. I'm surprised.
Complex networks?
SecureNAT.
Oh, that's actually pretty simple. Sorry. I don't know if you guys read the bios that we had up on the web page at all, but when I started with the group I'm with now, which is no longer the group I started with, but that's standard, I was brought on as an infrastructure tester for a product called NetDocs, and basically this was Office on the net. A grand design, and it was given to Office, and we went on and did other things. We had to run with ISA, and we did have a complex network where you had multiple routed segments. And the trick to this is, and it's actually you can set yourself up so that you can have greater security with this, because you can limit who is and who is not SecureNAT, is to make sure that each router in the chain on its way to ISA has a default route to the next router up the chain. And the last router in the chain has to use ISA as its default route. That way everybody in the network can be a SecureNAT. And if you have a segment, say the mailing section over here, that all they really need is web access to check FedEx returns, make them web clients and block the SecureNAT at your router. Did that answer the question?
Kinda. I thought SecureNAT allowed anything, like you couldn't limit GRE or IPv if it was SecureNAT.
Well, no, actually, it's just like with anything else on the ISA server. If you don't create a protocol rule for it, or in the case of SecureNAT PPTP, if you don't allow outbound PPTP, they're not getting through.
But I have to defend myself here.
Oh, I see. We're being bounced off each other. Okay. I see.
It's like on a mailing list. The problem is that you have no access control over non-TCP and UDP protocols. So if you set your route of last resort to the internal interface of the ISA server, and you have to set up a routing infrastructure to send clients to the internal interface of the ISA server.
That's true. ISA's not going to, ISA doesn't limit GRE according to source IP. That's something you'll have to do in your infrastructure.
Right, so that everybody that's configured with the default gateway then
Well, no.
Allowed access.
No, not if you can. That would be true if all you did was set a default gateway. But if you have the routing structure, say you have a IP47 source IP equals blah is blocked in your router, then they won't get through.
You're right, all right. So
Okay, it's not something you could do at the ISA server. That's correct. That is one of the things. One of the nice things that Service Pack 1A, B, whatever it's going to be when it finally shows up again, is going to do is also going to allow you to do filtering on incoming VPN connections. So that, and something I know Tom has seen a lot of on the news groups and the, in the ISA list is a lot of people who have to use VPN to connect to their DSL provider to get their IP address. So now everything's VPN and ISA blocks nothing. And that's one of the things that's going to be addressed there. So along the same lines as VPN.
It says, oh, cool.
Yes, I say, oh, cool, too, because there's a whole lot of questions. How do I do this? And the answer is, duh. Okay, that was a good one. And do you have anything that you're not trying to bounce me and Tom together? It is funny. I know the heads make this little box sound when they come together, but the ISA info script, I'm told that we don't have no connection out here. There's something that was written by a man named Chad Mossman at Microsoft, and essentially what he did was he took the original export script that comes on the CD, took all the mechanisms that are in there, and wrote something that actually provides a file to use to determine what's going on with the ISA server. And everybody knows it has used the MMC and gone through that and walked through ISA server and set it up and seen what's happening and what's going on. One of the limitations of any MMC interface is that while you're staring down deep in the guts of policy elements, protocol definitions, you've forgotten exactly what the particulars were for that protocol rule you set up that used the protocol definition you're trying to troubleshoot. The nice thing about the ISA info script is it puts all this together so you can just kind of walk back and forth through it, or you can bounce it against the MMC up in front of you. Right now we're up to version 1.4. Chad added a deal recently that he's going to try to trim down a little bit where it actually goes out and reads the event log. So now you have a whole list of everything the ISA server's been complaining about. As far as the log analysis itself, that gets to be fun. Do we have, we don't have a connection.
hold on. Do you have a wireless card?
Actually, I have, do you need, is it the wireless card you needed?
I got one here.
Okay, because I've got a system with all the, let me get,
This one's already set up. It works intermittently.
but we can try mine too. Let's see. Oh, so no, you're not going to cooperate. There we go. You have okay. All right, Tom, I don't know your computer. Where are you hiding the, there we go, term serve client. Let's see. We had this all planned out. We had all sorts of, I got RAS connections up to Gazoo sitting on my laptop over by Tom's legs. Come on, you know you want to work. Anyway, while we're waiting for this to actually happen, one of the things that I'm constantly telling people to do when they say, well, I've got this, I don't know how to read this in the logs, one of the things you want to do is go change the defaults for especially the firewall and web service logging. There are two fields in there called rule number 1 and rule number 2. And you want to turn those on, because what they'll do is they'll tell you whether or not you've been, the action that's been logged is appropriate to an allow rule or deny rule for rule number 1. And if there's actually a rule name involved as opposed to a default rule or a lack of a rule, it'll give you the name of that rule. So you can see or get an idea at least what's going on in your ISA server when it's not working.
The trick that worked earlier was to do an IP config,
Oh, do a renew?
release all, and then renew all. This is Windows Me.
Ah, okay.
I need a high security.
That's right, and you can't type CMD either. It has to be command. Oh, that's right. We really did practice this. I don't suppose they were nice enough to give us a hard tap up here, were they?
You set the SSID.
Do we have one?
The SSID is supposed to be black.
Like that.
Yeah, that's set up.
Okay.
Looking up you now.
I bet they don't have an ISA server running either, do they?
That would explain.
Yeah, that's right. What was one of the recent ones? Somebody put the firewall client on the DHCP server. Yeah. So my clients can't get DHCP. Okay. Well, while we're waiting to see if the local net will come back and talk to us. No, we didn't get it. 169 is an auto IP. Just go away. Thank you. All right, well, I don't have an example to show you. Good?
No, I laughed. I didn't say good.
Ah, okay. Oh, like there's a difference. Okay. Okay, well, one of the things to pay attention to is log analysis in particular, especially if you're trying to troubleshoot user or group-based policies. And also a huge bone of contention on the lists and news server is that ISA will log anonymous connections. I don't care how tightly you bind ISA to a user group in NT, you will still see anonymous connections, both from firewall clients and from web proxy clients, just because of the way the clients operate. Most of you guys already understand this. ISA doesn't provide the means for you to filter those out during logging. One of the requirements for ICSA certification was that ISA logs everything it sees regardless. The only place that you don't find this happening consistently or as a rule is in the packet filter service, where you can allow rules to be logged. You generally don't want that except when you're troubleshooting, because it makes for some huge logs. And especially if you turn everything on where you're logging all the headers and all the packet data, that's just nasty. You'll find very often it's very helpful to bounce the web logs against the firewall logs when you're trying to troubleshoot something that may or may not be using the web proxy service or the firewall service. For instance, if you're using SSL tunneling rather than SSL bridging for your outbound connections, you'll see the connections both in the web server, or the web proxy log, and in the firewall service log. And if you don't see it in both, then you know you have a problem somewhere in the HTTP redirector and the communications between the two services. The other thing is, don't forget basic Windows 2000 troubleshooting techniques. If you go look in your event log and you have, as we've seen many times, browser errors. Browser couldn't get the browse list from the master, yada, yada, yada. It's probably not an ISA problem. And in fact, on the ISA server, as Tom put out, oh, he went to sleep, didn't he? Okay. As Tom put out in a recent article, turn off the browser service. It serves no purpose on the ISA server, and in fact will assist in bringing you some information about the internal network should somebody actually get through the ISA server and start making fun with it. Oh, that helps. Well, you were busy, weren't you? Okay. The other thing is, one of the things you can do, and it's a trick I put in my recent client articles, is to turn off what I like to call a cache of death. Tom already covered this stuff, and it will make DNS troubleshooting, any sort of name resolution troubleshooting, much easier. You don't need those things in place. Turn them off, turn the cache size to 0, and you won't have to worry about it ever again. Make that registry hack part of your normal build-out process. Other things are, if you get, in fact I wrote a script for this because it happens so many times, people have a tendency to, they're familiar with setting up RAS manually, and they know what they're doing, they're just going to go do it. I got my ISA, I set up RAS, I know how to make the packet filters manually, it's going to work, it's no problem. And then for whatever reason, they added Service Pack 1 or some hotfix, now they have to reboot. The ISA control service won't start, the firewall service won't start, on. The problem you run into there is that RAS has to have a dependency on the ISA control service. If it doesn't, your ISA's dead every time you reboot. Or if your services should stop and you have them set to automatically restart. Let's see. Your basic network troubleshooting techniques. Go ahead and put Netmon on the ISA server. You're going to use it, I promise you. If you're not using it, you must have some other tool that you like better, because you're looking at data on the wire, I promise you. Some of the other problems we've seen is, like for instance, people want to set up automatic detection for both the firewall service and their web proxy, or their web proxy clients. This works really well until you fail to set up any sort of real name resolution system. All Win2K and better clients prefer DNS for name resolution. They will do NetBIOS broadcast, they will use WINS, but those will be the ones they use last. You put a DNS server in there, even on the ISA server, that's fine. For your internal resolution, you will have far fewer problems than most people do. One of the things that I've seen a lot too is if you ever have to unplug the ISA external NIC, you're going to have to restart the services when you plug it back in, because a whole lot of the PNP drivers for the NICs out there aren't as good as they think they are. And ISA is extremely picky about that. If the NIC goes away and it doesn't report itself back properly, as far as ISA is concerned, that doesn't exist anymore. You have no external interface. You get all sorts of errors in the event log. It just gets ugly. One of the things that you can do, something I've learned to do, is when you have alerts. Now, some people like to go and turn on all the alerts for the ISA server. That's just a confusion point. You probably shouldn't do that. The default alerts work really well. As far as setting them up for mailing and whatnot, all you have to do is make sure, since ISA services run as system account, they don't run as the administrator or anything else. In fact, that's one of the things that LandGuard blows up for you. What you have to do is set up credentials to talk to the SMTP server that you want to mail alerts from. The SMTP server, the SMTP alerts for one, this became a real big issue recently, won't tell you a whole lot. It just said, I had a bad command, and it'll throw some data down in the data portion of the blog. If you're seeing what you know to be data from the email, then you run into a problem where one of the SMTP commands was probably chunked together. The thing that we found out recently was, and I know everybody knew the original Service Pack 1 got pulled. We ran into a problem with the SMTP service, or the SMTP filter, where if you had an email server that would send 2 commands without waiting for the response from the mail server, it caused the SMTP filter to get upset. And it would say, invalid, I'm not accepting this mail, sorry, go away. Which, given the choice, I would rather throw away the mail based on a failure to obey RFC than let it through saying, well, okay, it must be okay. Let's see, I think that was the last one, wasn't it? No. I can't say yet. They're still working it out. I think so, yes. Well, they know what they fixed that caused it to break. So now they're trying to fix the fix that broke the fix that, yeah, on down the line. Basically, the ISA logs, as I said, as it's up here, the IP logs, and it starts with the IP whatever. If the packet filter refused it, it's here. And the best way to think of these is based on service, not based on traffic. Because as I said before, the firewall and the web server logs will often have the same traffic listed in them. You can have two configurations for the logs, W3C and ISA. I usually recommend people to use the W3C configuration because to me it's easier to read, except for the GMT thing, which a lot of people seem to have difficulty converting in their heads, which is not a big deal. And the ISA format tends to be more like an IIS log, so you might be able to use some of your IIS log parsers to read that and do some data mining if you don't want to log straight to SQL. As I said, the packet filter logs can log allowed traffic, but as a rule, you don't want that. It's great for troubleshooting, though, because one of the disadvantages to using packet filters to publish a service is that you have no logs. You have no record of any traffic coming or going for that service through those packet filters. I think this was a design decision by the ISA team, where you can set up an allow rule for a packet filter and choose to log the denials of that individually, but you can't say, well, I want to publish this with packet filters, log those. It may have just been too complex for the ship date. One of the things that I have found, and it might be one of your crib notes, is the one place that I have to counter Tom on publishing on the ISA server is DNS services.
You don't have to counter me.
Oh, okay.
You're right.
Well, I have yet.
Because of the UDP packet filter, I mean the UDP packet size limitation.
Well, that's yeah. But that was why Exchange uses TCP to do DNS lookups, because you have the UDP limitation. But we still should be able to do server publishing with DNS.
Right.
But that's the only service I'm aware of right now that you have to use packet filters to publish if it resides on the ISA. You can't server publish that one on the ISA for some reason. This is one thing. This is also where you find the web proxy logs. You find the client credentials in here only if the client is acting as a web proxy client, is making CERN 2.0 compatible proxy calls to the ISA server. If it's a SecureNAT client or a firewall client that's going through the HTTP redirector, it's gone. No credentials. And of course, if you have caching installed on the ISA and configured, anything that came from cache or was automatically downloaded for the cache, or the cache was updated or it was destroyed from the cache, that's all going to be in here. And the ISA help actually is pretty good on the log entries as far as what the cache was doing. The firewall service logs, these are great. These will help you figure out whether or not you've actually had return traffic from your originating traffic. Say you're trying to set up a net meeting session. You're trying to get together with somebody and work something out, but it's not working. And you've got your gatekeeper, and you set your phone numbers and your email and so on and so forth. You keep walking through your web proxy or your firewall proxy logs, and you find out that you're making a brand new connection. You hadn't seen this before. Something I found out when I was trying to figure out why you couldn't register with somebody else's gatekeeper was because the registration happens on port 1719, not port 1720. There's more to it than that, but the ISA doesn't allow that through even when the gatekeeper is enabled. It's only for behind people. The application event logs, those are your first best place to go to find out what's happening on your ISA server. There's some real good clues that happen there. For instance, if the firewall service determines that it has a misconfiguration, one of the really common ones is the intra-array IP address is not included in the LAT. Now, if I looked at your ISA info and it had that alert in there and said that to you, what would be the first thing that hit your mind? Nothing hit your mind. My God, I put them to sleep. Pardon? Okay, look at the LAT. Okay, that's the first inclination, but since your LAT is this big and the IP address for your intra-array address is this big, you probably have it in the LAT, don't you? In fact, that's your first question is, why are you telling me this? I know that IP address is in that subnet range. The problem is that it's just a generalized answer for any time that ISA determines that its internal IP doesn't match other settings, like the intra-array address. If you change that for whatever good reason you had, but you don't go in the registry or in AD and change this value in there for that server, you're going to get this firewall event log forever and ever and ever. And it's not clear enough to help you figure that out. Another application event log you'll see really often is when you have multiple servers in an array, and then they're all going to start arguing about what the array connection name is for web proxy and firewall clients, because they're all reading the same data from AD. And each one of them is going to come up with an alert that says, oh, you know, the configuration's incorrect. You need to go fix this. Actually, what you need to do is set up auto discovery and put a WPAD entry in your DNS and then change all of the client settings that Tom went through earlier to point to the WPAD entry in DNS rather than to each individual ISA server, and they'll quit complaining. It's a real basic problem they run into. Security event logs is really not a whole lot going on there unless you have ISA trying to do some sort of authentication for VPN or access to the ISA itself. And again, as I said, it depends on what the auditing you have set up. And the system event logs, generally what you find there are service failures. And the firewall service failed, web proxy service failed, you've seen those. The things that's not necessarily clear each time why they failed, and that's where you have to get into dependencies on RAS, and don't try to stop the telephony servers, that's bad. There's an ISA dependency on that one. Okay. Does anyone have any questions about troubleshooting ISA, or maybe even part of the client section, since I managed to stick time with that one? I'm going to be buying lots of beers for this guy tonight, tomorrow, next day. Nobody? Everybody wants to get out of here and go get a beer? Sure.
Maybe this is for Tom. How do you list the DNS cache if you do that and turn it on?
Oh, you're talking about the cache of death? You can't see it. It's stuffed in memory, and there's no utility or API that would let you see what's in there.
Just go in there and set the size to 0 and nuke it.
If you set that registry entry to 0, or in the case of AD, that property to 0, then you won't have to worry about the cache of death anymore. Now, one thing to bear in mind is that the ISA server resides on a Win2K server, so you have the DNS cache service running there. So you're still going to have name resolution. You're going to have whatever name resolution problems or perfect behavior that you define for the ISA server itself for each web or firewall client. Yes?
Have you seen any configuration of ISA that lends itself to compromise in any way? Is there anything that we need to, I mean, one, do you know of any way of, well, you probably can't tell us.
No, actually, if you're asking, is there any way to set up ISA so that it's useless?
Well, is there any way, have you seen deployments of ISA done in such a way that people could leverage the configuration in order to own the box from the net?
Absolutely. Yeah. In fact, this was one thing that was asked of Tom recently that I chimed in on the side and said, oh yeah, you can do this. The question was, can you set up ISA as a simple router, much like RASNAT? And the answer is yes, you can. The other question you have to ask yourself, obviously, that you're asking is, do you really want to do this? The answer is no, obviously. What you would do to accomplish this is to enable IP routing and IP packet filtering, and then disable IP packet filtering in IP packet filtering. And what you end up with is a basic router. It's not even as good as RASNAT.
Well, there's no NAT in that configuration because you're talking about
well, you still.
I mean, you can't route.
Well, you still have NAT. Yeah, that's the cool thing about it. You still have NAT, and you have extremely basic routing, but only internal to out. And of course, you can hit the ISA server with anything you want because the ISA is no longer filtering.
No, but what I'm saying is that
Go ahead.
it's not going to directly route to private address network.
No.
Right, but if you're talking about tri-home DMZ, then you have direct routing configuration.
Yeah, or even worse yet, because you've turned off packet filtering, the nice big red bar over here, you've got direct access to the ISA server itself, so now you can get in there and configure it however you want. You can do whatever, especially, I believe you asked the question about whether or not it was worth making ISA one of the AD controllers. And of course, Tom had the right answer there, absolutely not. You don't get a choice with Small Business Server 2000, which is why you want to be extremely careful how you configure ISA on that box, because it only takes one. In fact, I don't remember if that slide had that. Possibly not. No. Nope. Okay, I didn't add that one in. Basically, if you set it up the way I just described, you have a wide open server. You might as well not have ISA Server installed at all. I'm not exactly clear why that option was allowed. It might have just been testing or design oversight. I don't know. It's not how I would have done it, certainly.
And of course, we could configure it as a VPN server, you know, and have users have mom and dog as their password.
Right.
Yeah.
Right. And you said that the new service pack is going to allow me to filter the VPN traffic now?
Yes, one of the things that they tried to address with the service pack is, please feel free to test the hell out of it, is that they wanted to be able to filter VPN connections. I guess they didn't realize when they originally built ISA Server that a lot of our European friends, when they connect to their DSL providers, actually have to use a VPN connection.
But that POFH,
POFH?
packet filter only applies to VPN connections that originate at the ISA server. It doesn't apply to internal network clients.
Right. That's an excellent point. I don't know if everyone caught that. The packet filtering that's being applied to the VPN connection is can only be applied to the VPN connection that terminates at the ISA server itself or originates there. Of course, the obvious reason is if you have a SecureNAT client that's using your SecureNAT PPTP outbound packet filter, your traffic's encrypted. You can't read it anyway. So it's impossible to filter. Boy, it's quiet in here. Okay. No one else has any questions? Comments? Something I should take back to the ISA team? Likes, dislikes, gripes, grumbles? Talking too long?
Port redirection for server publishing.
Oh, absolutely. That's.
That's another question.
Did you verify that SP1 now includes port 445 and the NetBIOS and all filter?
No, I can't. And it's not NDA, I don't know.
The only way you're going to block that is to disable MVP.zip.
Well, what?
Actually,
All filter that's currently that's in the regular product.
Oh, you're talking about the NetBIOS all filter. No, I don't know. And
NetBIOS all filter. It doesn't include 445.
Okay. Oh,
So
yeah,
if you
I see.
say block NetBIOS all, it's only 139. It's TCP 139, UDP 137, 130.
that's an excellent question. And
do 445. So it gives you a false sense of security. So I just wanted to ensure that that was included.
I'll ask him about that. It's not something I was aware of it peripherally, but not directly.
Especially since Microsoft had an issue with the direct host port a few months ago. They had a small security issue.
You could say that.
Yeah. Don't we all have it?
Yeah. Okay.
All right.
Is that it? Must be time for beer. Okay. Thank you, Tom, covering for me for so long.